Hello, everybody. My name is Álvaro Leiva Gaise. I'm a production engineer at Facebook and Instagram, and I'm here to talk to you about solving all the problems with systemd. So the first question that you have in your mind is, really? Like all the problems? Yes, we're going to solve all the problems. Eh, well, except if you run BSD, Mac, or Windows. In that case, you're on the wrong talk, but that's fine. You may stick around. Okay, cool. So let's dive right into this. Systemd is many things to many people, but what most people tend to agree on it is that systemd is a service manager, right? So the first question that we need to answer to understand what we're going to do is, what is a service manager? And a service manager is basically something that manages your service. As stupid as that sounds, that means that a service manager is not NGINX, it's not Apache, it's not Cassandra. It's the thing that we use to manage that. And what do we mean by manage? It's something that we define operations. So your service manager is supposed to start, to stop, and to manage the life cycle of your application. Should my web server start when I boot my machine? Or should it start right after my database start? Like, it should coordinate those things. So that's what a service manager do. In the good old days, like about 10 years ago, we have System 5, right? System 5 was great. Like, people love it. But that means that you were your own service manager. That means that if you write something that is called my app, if you want to manage it, if you want to start it, you need to write your own shell script. And you put them like initc, initd, my app, and you run it. So and probably most of us remember the times where we need to write stuff like this. And we think that it was great, right? Because we basically write a batch script, and this batch script allows us to do everything. So if we want to start in the most unorthodox way our applications, we could. But then we grow up, and then we realize that having that kind of freedom is not necessarily the best thing. So for instance, right now here, the guy who wrote this script decided that he wants to have a start, a stop, and then for some reason he decided that restart and force reload were the same thing. That may or may not be the same case for a second service that you're going to start, right? So this is Cassandra, but maybe force reload for NGINX doesn't mean restart the service. Now and also comes things like that. Like if we just focus on start, you see that the only thing that actually starts your service is line 110. Everything else is dealing with argument parsing. It's dealing with verbose output. So you needed to do all these things to manage your service. So even though it was great, it has its flaws. So then after a while, it came systemd. For the Linux community and many other architectures also, we decided that System 5 was great, but it was actually slowing us down. It didn't allow us to start our services faster. It didn't allow to actually stop our services faster. It didn't allow to bring things, and it also made like really complex to manage new services. So as always, this happens. People propose solution. Two of those solutions always get to the top. They get into a war, and then one of them win. In the case of Linux, this was Upstart and systemd, and after a while, systemd won that war. And here's kind of the first bit of this talk, and here's kind of the first mindset that I would like you guys to take with this. It's not that systemd is good or bad. That's up to you to decide. But it's more systemd is a fact of life. It's on your machine, and it's probably deployed on all of your servers. So why don't we just take advantage of it? And that is kind of the idea here. So why systemd became so popular, or what it makes it apart from the other service manager? First of all, in systemd, unlike System 5, you don't actually tell it how to do things, you just tell it what to do. You say, systemd, can you start my service? And systemd will start it for you. And you let systemd decide what is the best way to do this. And the good thing about this is that if you say, systemd, can you start my service in the ch root? It can actually not do that. It can just start it on a namespace, because like technology advances and we don't do ch root, we do namespace right now. So by letting systemd do this for you, you actually don't need to modify your things and just let the times roll. Okay, so how does this work? And I hope I'm not presenting anything new to people, but in systemd, you don't have shell script, you have unit files. And if these unit files end with .service, you have a service. So in this service, it's a key value file that you can specify all the things that your service have. For instance, here it said, this is the user, this is the working directory, and this is how you start my app. you can see that I actually never say to systemd to change to a directory, you have to do cd and then do this. You just let systemd decide how to do the thing best. So since that file is not executable, you cannot just write dot that path and wait for something to happen. You ask systemd to start your service. How you do that? You do systemctl start, and then systemd will start your service. If you want to stop it, you do systemctl stop your service. And here's the first win. I never specify how to stop my service. Systemd knows that since this is a relevant, like a normal Unix service, it knows exactly how to stop it. But all this is kind of opinionated. If you should start your service, if systemd should start it, it really it's your opinion. If you think this is wrong, that's fine. But here's the main difference. By you allowing systemd to manage your services, you get all this information that now you think is obvious. Like, if I manage a service, I want to know if my service is running. But before systemd, this was really hard because you actually had to write the status command. Like, do you guys remember etc init httpd status? And that is something that you need to write. Now, with systemd, since systemd is the one who actually did the first fork, exec, he can keep track of that PID. Also, since he started, he can tell you the uptime, which is something like, oh, this is something that I really want to know. Now you have it. And this was a really hard question to answer, especially for all of us who manage Apache web servers before. It's like, how do you know all the process that was started by your process, right? So do you remember the time when we have an Apache web server and those things would run CGIs, and those CGI eventually decided to double fork itself and become daemons, and now those things are running loose on your service? Yeah, so systemd can keep track of all those things. And the way that it does that is by using cgroups. So this would not be a systemd talk if I didn't talk about what cgroups are. So let's do that. So cgroups is a feature of the Linux kernel that allows you to impose limit of resources on a collection of processes. I always read that thing, try to do that verbose. But in plain Linux terms, that means that you can actually impose to a service that you have or a process, you can say you can only use 20% of CPU, or you can only use 10 megabytes of RAM. So that's what cgroups are. Systemd uses cgroups in a slightly different way. It uses that to impose restriction, but it also does the following thing. For every service that you start on your machine, it will create a special cgroup for that service, and then will start your service there. What's the implication of this? The first thing is that you create your application, and then your application decides to start child processes. Super easy. If you want to know which are the child processes, you have the PID 632, and then you see the process tree for that, and you're good. How about if one of those processes decides to demonize itself? Like, how do you keep track? Now it's no longer part of the process tree. From the system point of view, there's no difference between your process and the other one. But in modern Linux systems, since that start in the same cgroup as the main process, you can actually find them by just looking at the whole cgroup as a one structure. So this one, so in the old days, if we wanted to kill a process, we just find the main PID, and then we kill everything else. But then we will just leave this daemon process hanging out. Now with systemd is the first time in the whole of Linux history where we can actually kill an entire services. And the way that we do that is instead of trying to find or track PIDs, we just shoot the cgroups in the head. And that's it. Cool. So that was the first part of the talk where I was just trying to introduce systemd. Now let's see a few things, cool things that we could do with systemd. I want to start with the simplest things that, at least from my point of view, people tend to say that this is not really useful, but damn, it's really useful. We use it a lot. So, okay, so templates. Templates is a way to define like services that you can configure on the fly. How does this work? So I have my app.service, but instead of calling it my app.service, I call it my app@.service, or an arroba, how we would say it. So by putting that up, and then you put these little markers there, this %i, you can actually do quite cool things. The first one is that when you want to start your service, you just started like my app at, and then you put a word. And that word can be anything. So when your service starts, what it will happen is that you will replace this %i with that word. And this seems silly or something that you may not use, but it's super powerful. Since that word can be anything, it can be the port in which you want to listen your application. So you can have multiple instances. You can start MySQL at 3306, 3307, 3309, and then you will have, with the same unit file, without making any modification, different instances of MySQL. The other thing that you can do with this is if you make that at the version of your application, so you can, or the hash of the commit hash, or the git hash, sorry, for your application, you can actually have different instances of your same application running on different commits. So if you do my app at master, or my app at my silly branch for trying cat pictures, you can actually make your application run like this. And from the point of view of the developer, it's just like adding exactly the commit that you want. So this thing is cool, and now we can use it with other things. Remember when I say like this would not be a systemd talk if I didn't talk about cgroup? Well, this also would not be a systemd talk if I didn't talk about socket activation. So normally your application, this is kind of the normal workflow of your application. You start your app decided to listen into a port, that become an open file for your application, then somebody sent you a like, and then you send them a heart. Right? So there's this kind of workflow where you have your application listen to a port, you get request. Needless to say that if your application is down, when somebody sends you a like the port is closed, the open descriptor is closed, and then people are sad. Socket activation kind of changes paradigm in trying to do something different. So instead of being you or your application the one that listens to the port, you allow systemd to listen to the port for you. So systemd open this file, and then he has it. And opening a file is a pretty inexpensive operation. You just do it pretty fast. And I won't talk about this, but this is the reason why Linux system boots so fast today. Okay, so systemd open that file. Then a request comes, and then systemd says, great, I have a request. I will start your service. So now you didn't have your machine like before this, you had to start your service for start listening to something, and that slowed down everything else. Now you're not wasting resource. You only start your application when you need it. And then systemd will gladly pass the file descriptor to your application, and then your application can use whatever it wants with that socket. And then, of course, you get the response back. So a few implications here. The first thing is that you can use this not even in production, not even for deploying your service. Just imagine like your dev machine. Like you have a web developer who has a MySQL database in his machine and also has like his Apache, but he never actually queried the database unless when he's running like 1 or 2 tests. Why would you have a MySQL running on that dev servers every day? So you just make that MySQL start only when the developer is running that one test, and that will make his life very, very great. The other thing that it happened here is that since systemd is the one that starts the port, like listening to the port, and not the application, you can run like the port run as root, right? By the way, I'm a Python developer. That's why I name my root user as Guido. That never caused me any issue, renaming the root user. So my application, so the systemd start listening to the port as root, and then my application don't need to run as root. My application can run as any user. This has the following implication, is that normally what you would do, your application will start a root, then open the port, then it will either de-escalate itself, or it will start processes in another user. The problem with that is that all that logic has to live in your application. And that logic, that means that you have to unit test. That means that is code that you have to support. With systemd, you just say like, hey, start as this user. And then you don't even care about what port you're listening. The final thing that is cool is that if you combine this with templates, you can actually make your application like listening to version 1 of your application. You start. And then you decide that you want to upgrade. So you start version 2. Then you do your A/B testing because systemd can open the port twice. You decided that your version 2 is good enough to be put into production. And then you kill your version 1, and you make your version 2 the one. And this is how you can do a simple deployment, zero downtime deployment, just using systemd. How does this work? It's super easy. You have a service file. Now you have a socket file. Great. That socket file, you specify where you want to listen. You just say like reuse port so we can have multiple instances of it. And then in your application, you are used to do this, right? You open the socket, you bind, and then you listen to something. What now you do, since all these operations are already taken care of for you, you just do socket from file descriptor. This is Python, but you can do this in any language. You just specify the file descriptor that is passed to you through that thing, and then you're done. Like you don't even need to listen or anything. So yeah. In Facebook, we love Python, we love systemd, so we decided to create a Python library for it. I will go through really fast through this because I'm not really here to promote this tool, but it allows you to give a Pythonic way to actually interact with systemd in a way that it looks and feels like I'm actually writing code and not just shelling out to do something. And the reason why it feels like this is because you're talking to systemd through divas. So you can start, stop application, you can get all this data that we have talked, you can call methods. Cool, so that's finished that. So now I'm going to show you a few cool things that you can do with systemd like in the real world. Okay, so yeah, I think that's good enough. Okay, cool. So let's start like this. So in a normal application, if you want to run a shell script, or you want to shell out, you run something like subprocess.run, right? What this will do is that it will start a subprocess that is a child of the parent that is running, and it has all the restrictions that it has. Like it started on the same C group, it has the same view of the system. If, for instance, for some reason somebody would kill minidemo.py, it will also kill the sleep process. With my library that I created, and the only reason why I show you this is because we're going to need it for the demo, I can do systemd.run, and then what it will happen is that it will start the sleep process in its own service. So it will literally create a systemd process on the fly. If I start this and then I do status, you will see that systemd actually created a service for that process. And if I go and I'm curious, and then actually look at that file, you will see that it's like a normal file. It was just created on the fly. So here's a couple of things. Here's a couple of cool things that you can do with systemd. So let's start with this. Oh, by the way, here I'm showing you what would be the unit that you will need to create in order to achieve the same thing through normal systemd and not using systemd. And these are all the things that are even they're not really comprehensive, but are here to kind of inspire your curiosity on things that you can do. So let's start. So you see that there are two options here, right? Protect home and protect system. Protect home is a feature that you can do, and imagine you start your web app, and then you just make your web app, for your web app, you make home completely invisible. So home, of course, I have users, so they should be like their user files there. But for this application that I'm running right now, it doesn't have access to home. It's even better. It doesn't have access to root. So my application, right now, I'm running it, but from his point of view, from his namespace, it doesn't have access to any of those things. That's protect home equals true. There are variations to this, but we will see them later. Protect system is actually quite cool. Like, how many of us run services that actually don't need to write anything into file? Sorry, don't need to write anything into disk. So, great, thank you. Who else? Yeah, thank you very much. Okay, cool. I'm really hoping that this connects to everybody. But yeah, so when you do protect system equals strict, you can, right, I need to learn how to write. You can do, for my service, the whole system is read-only. So you cannot actually write. And this is awesome because if you have a script that reads from a database, processes that data, and if there is something that needs to trigger an alert, why would you give it access to modify ls, right? Why would a service in your system be able to modify echo, right? So you don't allow it. And again, if somebody hacks that service, then it doesn't have you limit exposure. So that's one. What else can we do? Okay, so the two things that I've shown you are basically like catch-all. Like they are like brother. Here's a few things that are more discrete. So read-only directories, it's when actually, what if I actually want my application to be able to at least read the root directory? Not modify it, but just read it, because it needs to access my AWS credentials. So you do that. Inaccessible directories is the same thing that you saw, makes the directory completely invisible to the service. And then read-write directories is pretty obvious. A couple of things. Private TMP, it's something that it will mount a special TMP just for your service. So like the TMP folder for your service is completely separated from the rest of your service. And also, you can apply these same things to any arbitrary by using temporary file system. So if you see, if I go here and then do, you will see that actually var cache MyS is mounted as a tempfs. What's cool about this is that everything that I put there goes away once my service stops. So the life cycle of my temporary files is actually tied to the life cycle of my application. And this is something that we all want. Finally, is that since we already can make this go away and make file system read-only and stuff like that, why don't we just mount file system one over another? So one thing that, for instance, you see is that var lib MyS is actually mounted from one place to another, right? So that is not really that is not really a directory, there is a mount for another. And the other thing that you can do that is actually quite cool, let me see if I can do it. So without yes, I want to execute this. So you can actually also mount files, mount executables. If you're a developer, you can actually make if you want, for instance, you can mount a different version of USR lib to your application. That way you can have different SOs. Okay. So let me do that, right? Okay, cool. So I hope that would give you curiosity. This one is the coolest one, and I really think that this may interest some people. So you give access to the file system, you can restrict it. How about you restrict the network? 10? Okay, thank you. So okay, we have enough. Yeah. So how about you restrict access to the network? Right? So for instance, in this case, just this service doesn't have access to anything in the network. There is the 000/0 except 888/32. So this application can only actually ping, well, it can do more things than ping, but it can ping. Great, I literally don't have internet right now. Okay, you could only ping 888, and then 44 will do. Yes, so you see the difference between one of the other. One is just my machine not being connected to the internet. The other one is I actually forbidden the access to that IP. So you can actually make a private firewall just for your service in case that your service need. In case that, for instance, if you have a service that only talks to a database, why would you give it access to your whole network? And you can do that at the service level. And this is something that systemd can allow you to do. The next one. The next one is about C groups. So you can start an application, and then you can say, hey, you know what? This application, can you have just 20% of the CPU available? Can you please also just use 10 megabytes of memory? And this will I'll explain later. So for instance, I will do this code that I learned when I was in high school. So if you want to, you can do, great. So as you can see, I'm really trying to abuse the CPU here. And as you can see, my application that is right there could not use more, approximately more than 20% of CPU. So imagine you're in your application, you have a piece of code that you don't want it to really use all the CPU. You just say, hey, don't use anymore. Okay, so that's one. And now for the memory, I can literally do LISA18 and then try to, let me see if I can. Yes. So basically what I tried to do, I tried to use more memory than possible. Basically, I was trying to create a really long string and fit it into memory. Then since I give it a restriction of 10 megabytes, the killer decided, oh, this C group is actually going over the memory limit. Oh, it's only this application in this C group that I need to kill. So it did the right thing. It just killed Python and not the bash. And then the task is the number of forks that I can do. So, okay. Let me just show this so you can understand. I put a limit on the task. As you can see, I have 3 applications running, bash, systemctl, and then the less that is kind of showing you. By you putting a limit of task is the number of times that your applications can fork. And then that would be a halt in my presentation. Let's see if I can show you the last thing. Just because I really think this is cool. So, chroots. This is one step before going into containers. And if this talk works 15 minutes later, we will actually create a container through this, but we're not going to do that. So what's happened? I just said, can you mount my application in this root directory? And what that did is that you all see that I'm running Arch, right? Cool. So what I did is that by mounting my application, then I do etc os release, and it says, oh, it turns out that I think that I'm a Debian. And that's cool because I actually have apt. And now, so basically, it's just a real common like chroot. It's like this close to be a container. And if you put all the pieces that I teach you together today, you will actually make a service as a container. Just add it as that is. And that would be the extent of my presentation. Thank you very much, guys. By the way, to motivate for questions, I really hope you have. If you don't have, you don't need to go in front. I have Instagram stickers, which are the currency, the modern currency. So, any questions?
Questions at the microphone.
Hi. Is there any way to make it not kill your process if you use all the memory? Can you just halt it, or? I know it's the ohm killer that does it, but
yes. So it's the kernel ohm killer. There are efforts, and Facebook has a really cool effort that if you actually want to review into that, you can do it. We created a daemon called omd because you have to put a d at the end of everything. That is actually like it acts before the ohm killer and makes like random decisions for you. Not random, sorry, like custom decisions. So you can say instead of actually killing my process, can you just freeze it and then try to run it again when you have more memory? Yes, you can do that, but not with the ohm killer. So this is systemd just imposing the restriction and letting the Linux kernel do its job.
Okay,
cool.
Thank you.
Hey, great talk. Are there any other good resources to learn about systemd that you can recommend?
So
to find out more.
Okay, so resource. Okay, so as we all are all nerds and geeks. So I would really recommend the man pages for systemd. They're really good. With that said. Yeah. Do you guys know the creator of this, Leonard Pottering? He gave a talk last year and last year in All System Go. There's a conference in Berlin that is on YouTube. I would really recommend YouTube. Sorry, Leonard Pottering, All System Go, and that's awesome.
Okay, thank you.
In your example using templates, you said systemd can open port 80 twice. What on earth do you mean?
Okay, so I can show that because two things. There you go. So there is a flag that you can give when you open a port that is called SO_reuse port. And you can do that like in any normal application, but there are like a lot of restrictions. Like the process has to be the same parent child. There are restrictions. Systemd will take advantage of that and will basically ask the kernel, hey, I am the same process. I can open this file twice. Let me. And then the kernel will say, yes, I will let you.
But then how do you dispatch the traffic to the right service?
So this is done for the kernel. So this is done by the kernel. And this is assuming that you can have twice the memory. When you open the port twice, the kernel will just load balance between the two processes. With that said, when you're shutting down one of the services, you can let systemd, hey, I'm shutting down. And the systemd will, let all connections still alive, and so that way you can drain it, but it will redirect all the new connections to the new service. But most of this is magic done by the kernel, which we all know it's a magical thing. So, bless you. By the way, everybody who has made question, ask me for stickers. Everybody can ask me for stickers.
I had a question. If you wanted to have multiple services that fit inside the same service slice, could you do that through transient, or do you have to predefine the service ahead of time?
There are two ways to do that. One is only available in systemd 239. That is like you can start a process and then just shift it to another C group.
Okay.
Like right there. And that's a systemd call that you can use with systemd. The other thing that you can do is that through a thing called systemd nspawn, you can start a service as a container, and then you just talk to that systemd and tell, hey, can you start this service for me? But it's systemd all the way down. Right.
Thank you.
You're welcome. Cool. Thank you very much, guys, for coming.